Hello student. Today we were already discussing, our session is just going on about the work energy and power, and today we have assembled here to just meet with another important topics. So we will discuss one by one. We have already discussed that how kinetic energy and potential energy have their role in our daily life and what is their basic definition. I have given the clear concept about those topics. Now today's topic is the work energy theorem. Okay, so dear student, you already know that uh, initially here, just on a surface, a smooth surface, initially a block is just here with initial velocity u is here, means initial velocity means u equal to 0 at rest, the body is in rest. But whenever we apply a force on this particular just body, it will just displace from one position to another position, and its velocity also increases from u to v, and it also cover a distance of s. So obviously when we apply a force, the body displaces from one position to another position, okay, with some velocity, with the rate of change of velocity, okay, with some acceleration also, it will gain some acquire some acceleration, and obviously it will cover distance s. Okay, so what work energy theorem states, what is the phenomena, the work energy theorem, what is this theorem states? According to this theorem, the work done by force, means whatever the work done from initial to final position, it displaces some distance also here. So the total work done by this force, applied force, on a moving body, on a moving body in the same direction, is equal to the increase in its kinetic energy. Okay, this is what about the work energy theorem. That is, whenever a force is applied, the body displaces from one position to another position in the direction of motion of body, and it accelerates the motion, and it thus increase the kinetic energy of the body. That is, suppose a body is just moving with the initial velocity u, okay, the body is moving with initial velocity u, and when just external force is applied on the initial velocity, then it increases its velocity, okay, with some rate, okay, and this is what as the total work done by the moving body when an external force is applied on a body is equal to the increase in its kinetic energy, and this is what the statement of work energy and theorem. So obviously the body changes when we apply a force, the body changes its position from u to v, okay, and suppose its mass is also m, the body has mass m, okay. When a constant force is applied to the body along the direction of motion, it produces acceleration a, and velocity of the body changes from u to v in the just moving a distance s. Here is a distance s. So what we know about the definition of force, that is, we know that F equal to what, m into a, according to Newton's second law, that is force is equal to the product of mass into acceleration produced in the body, and just direction of the motion is in the direction in which the force applied. So this is what the force, this is a constant force applying, F equal to ma, okay. If we consider it as equation 1, and just work done, what is the work done? We know that work done is equals to always force into displacement s. This thing also we know that whatever the work is applied, it produces just force into displacement, okay. This is what the work done. So we also know that the work done equal to fs cos theta. Here is the direction, this is the direction is in which the force applied, mean displacement of force is in the same direction, so cos theta will be 0 and value will be w equal to fs. Now one condition is here, that we can write here from also one relation. We also know that we can write here that w equal to, we can put here that ma into s, Okay, we have just, suppose this is equation 2, so putting equation 1 in equation 2, so its value, work done will be MAS. Now from the suppose the body is in motion, so one thing also we have to keep in your mind, that it has some motion, so we can apply the relation, that is V square minus U square equal to, we can write it 2AS, and from here only we able to find out the distance. Okay, how we will able to find out the distance? S will be equal to U square, suppose V square minus U square, okay, upon 2A, and this will be equation 3. Now put this equation in equation, just in this one. Okay, so we are writing here, we know that work done equal to what? MAS, and M into acceleration into what the value of V square U square upon 2A. Okay, so here is acceleration cancelled out, and we can write here that 1 by 2 M V square minus U square. Okay, so this is what as we can write 1 by 2 into, we can write here 1 by 2 mv square minus 1 by 2 mu square, and this is what the work done, it is imparting it in increase in its kinetic energy. So this is what as the kinetic energy of the final velocity, minus kinetic energy of the initial velocity, and this is what the difference is, what equal to, that is work done. So this is what is the work energy and work energy theorem. This is the required expression for the work energy theorem. Okay, now we will discuss one very important topic, that is, okay student, here with this concept we will able to just verify that how potential energy and kinetic energy remains conserved in the whole universe. That is, we can say that we are going to discuss about the law of conservation of energy. Okay, in the previous classes we have also learned that energy cannot be created. Okay, according to the principle of conservation of energy, what we know, we know that energy cannot be created. Okay, nor can it be destroyed, but what happens, only it changes its forms from one form to another form, and the sum total of all the energy remains constant in the whole system. So this is the statement of law of conservation of energy, and this thing, with the help of this condition, when a body is just placed at some height above the ground, and we will just verify that how the sum of potential energy and the kinetic energy remain conserved in each and every case at A, B and C. Okay, so dear student, just look at, that is, suppose a body is at position A. Okay, means we are placing a body at position A, okay, at height h above the ground. So in this case, at the maximum richest point, okay, its initial velocity will be here. Initial velocity will be when it is falling freely under the ground, just falling freely toward the center of gravity. Then at this point, what at this point will be, initial velocity will be 0. Okay, if the initial velocity will be 0 at this point, at point A, when it is just upward at a height h or a displacement h from the ground, initial velocity will be 0. So what will be the effect of kinetic energy? What will be kinetic energy? Kinetic energy will be what? Kinetic energy will be equal to 0, because velocity is 0, kinetic energy is 0, and we know that the potential energy is always the work done against the gravity. Okay, against the gravity. So at the richest point, the potential energy is maximum, because maximum height, it is placed at the under of height. Okay, maximum distance displacement is covered. Work done against the gravity is what? Potential energy. So here potential energy is maximum, so we can write here potential energy, that is U. Okay, that is U equal to what? Mgh. So what we are getting here, at richest point the sum of kinetic energy and potential energy, what, 0 plus mgh equal to what, mgh. So here we are getting the mgh. Now suppose at position A it just coming towards the surface of earth under the action of gravity with it reaches point B at a distance of x. Suppose this is it covering a distance of x. Okay, it is curving downward and it covers a distance from A to it has reaches at point B. Okay, and this will be what, this BC will be in the upward direction, this will be BC will be what, h minus x. Okay, so at point B, suppose from falling from A to B it is covering a displacement of x. So at point B gradually the distance gradually the height is decreasing. Means what, if the height is decreasing, so its potential energy is also decreasing, but the rate at which the potential energy decreasing, the rate at which the kinetic energy increasing is increasing also. In the same phenomena that the two processes takes place. Okay, means increasing of kinetic energy will decrease the potential energy gradually, and this two phenomena takes place simultaneously. Okay, so with just suppose a body just had reached at point B, then obviously it has acquired some velocity from reaching from point A to B. Suppose it just taken at condition okay, then obviously when the body is at point A and it's just coming to B, what will be its initial velocity here at B? Just falling freely with initial velocity u. So in this case also, what is u? Initial velocity is 0. Okay, and suppose it is acquiring with final velocity some v1. Okay, suppose it is acquiring v1, it is coming downward with v1 velocity and it reaches at point B, and initial velocity is u is 0, and because if it is falling from the point A and at this point the body is at rest condition, so initial velocity is 0 and it acquiring the final velocity v1. So in this case, and covering a distance of x, so what we are getting from it, okay, and acceleration, it has some acceleration, and when we know that when the body is in we are falling upward or downward, acceleration is equal to just it will become g. Okay, acceleration due to gravity. So from relation what we can write, we are just talking about at point B. Okay, so we can write v square equal to u square equal to plus 2 as. Okay, so v square equal to u square, we can write 2gs because a is g here. Okay, displacement is what, displacement here is x, so is covering a displacement x, so we can write x instead of s, so we can write v square equal to u square plus 2gx. Initial velocity is 0, okay, it is we can write here v1. Okay, v1 is square because it is squaring, it has acquired a velocity v1 from falling freely. Okay, so this is the main formula, we can write v1 here. So v1 square equal to what, 0 plus 2gx. Okay, this is the just velocity, final velocity equal to 2gx. And what we know about the kinetic energy, because although it has some kinetic energy because it is moving downward, okay, it is not at a rest position, it is a motion. So kinetic energy will be what, kinetic energy equal to, we know that half mv1 square, we can write here. So we can place it half into m1 into 2gx, we will write here. Suppose this is 1, we are using equation 1 into, and suppose in this equation, so half m v1, we are putting the value of v1 here, so 2gx. Okay, 2 cancelled out, so kinetic energy is equal to what, mgx. Okay, now this is what kinetic energy equal to mgx. This is the statement. Now we can describe it as, now we able to find out the potential energy at point B, because it has some potential energy, because it has some height from the ground, so its height will be h minus x here. So we will take here. So now at point B, the height of body above the ground is h minus x. Above the ground is h minus x. The height of the body at B above the ground is h minus x. So we can write here that potential energy will be what? Potential energy, that is U. We can write here U is equal to mg h minus x. If you write here equation 2 and 3, we will, if this equation is added, kinetic energy plus potential energy equal to what? Kinetic energy is mgx plus this will be mg h minus x. Just add it, mgx plus mgh minus mgx. Okay, this is h, this is x. Okay, this will cancelled out. So the sum total of energy what we are getting here equal to mgh. At the richest point also we are getting the sum mgh, and in the at point B we are adding the sum of kinetic energy plus potential energy, we are also getting here at point B as mgh. Means what we are getting, that we are getting here that the sum total of energy, if we are adding all the kinetic energy at every point, we are getting mgh. Means that energy is constant, energy is the same. So this is what the law of conservation of energy. But if we consider at point C, okay, suppose here is a point C, we can just will discuss. Suppose at point C, if you are discuss, then what at point C on the ground, suppose on the ground, suppose in the on the ground C, what we are getting here, velocity acquired by the body on reaching the ground be v. Suppose now from B it is just coming downward with velocity v. Okay, so what we will just getting here, so at position, just at this position, okay, at this position, suppose at this position initial velocity is again u equal to 0 here. Okay, here u equal to again 0. Okay, at this particular point we are considering here that the body is just falling from the initial, suppose this is initial position we are calculating at different points, but at the initial position A the initial velocity is 0. So considering we are just initial velocity is 0 only, because we have considering from A to C, A to B we have calculated here at point C. So initial velocity is 0 at the initially, and suppose through total displacement is taking h from here to here only, total is h. Acceleration A is also equal to g. Okay, so again we apply the same procedures, that is we know that v square equal to u square plus what 2as. Okay, v square, this will be 0 and this will be 2, this is g, and displacement is what, h. So v square equal to what, 2g h. Okay, so kinetic energy at the ground will be what, half mv square, half into m into v square is what, 2gh, 2 take cancelled out, and this is mgh. This is what, mgh at the ground at the point C. Okay, mgh. And what about the kinetic energy, potential energy at point C? Potential energy will be 0. Why? Because there is no work done against gravity, here height is 0, so u equal to 0. And if we add all the kinetic energy plus potential energy, okay, it will be what, 0 plus mgh, or we can write here mgh plus 0. We can write here mgh plus 0, and the final we are getting mgh. Means at the whole system what we are getting at point also the energy is mgh, at point B the energy is mgh, at point C that is energy is same. In the whole system the just energy is conserved or the same. This is what the law of conservation of energy, that energy cannot be created nor does it destroyed, but its forms can be changed from one form to another form, and the sum total of all the energy in the whole universe remains constant. Okay student, up to this you just go through the topics. We will meet in the next video. Thank you.